Hi guys, this is Miss Valdez, and in this video I'm going to work through the lesson 6 through 10 practice quiz. So hopefully this helps answer any questions you might have. Let's get right to it. So in number 1, we're first going to distribute this negative. So we have x cubed plus 6x squared minus 4x plus 7 minus 3x squared minus 2x plus 4. Now we'll combine like terms. So x cubed doesn't have anything to combine. This 6x squared can be combined with this minus 3x squared, which will give us plus 3x squared. This minus 4x and minus 2x gives us minus 6x. And then plus 7 plus 4 is plus 11. So that is it for number 1. Number 2, I'm going to start by foiling. So this is 2x squared minus 18x plus 5x minus 45. And then I still have this 8 out front that I need to work with. So now we're going to distribute that. First, though, I think I'm going to combine my like terms. So this is 8 times 2x squared minus 13x minus 45. And then at this point, let's go ahead and distribute that 8. So we get 16x squared. 8 times 13 will give you minus 104x. And then 8 times 45, that's going to be minus 360. So that is your answer there. All right, number 3 is also a foiling problem. You need to rewrite this as 10m minus 3y twice. And then if we FOIL this, we get 100m squared minus 30my, and then another minus 30my, and then plus 9y squared. And if we combine those like terms, we get 100m squared minus 60my plus 9y squared. That is your answer there. All right, this next problem, I'm going to do it the long way because that's probably what most of you guys are used to. So first, let's distribute this negative here. Make this x squared minus x minus 1. And then since this is just a plus in the second parentheses, we can just drop the parentheses around the x plus 1. So now if we start distributing, x squared times x squared is x to the 4th. X squared times x is plus x cubed. X squared times 1 is plus x squared. Now distribute the negative x, you get a minus x cubed minus x squared minus x. And then we'll distribute the negative 1. I don't know, let's just use purple. Okay, so the negative 1, we get minus x squared minus x, and then minus 1 at the end. Now we're going to combine our like terms. So I only have this x to the 4th all by itself. I have a plus x cubed and a minus x cubed, so those are actually going to cancel. And then same with the x squareds. This x squared and this x squared cancel. But I do still have this minus x squared at towards the end here. All right, then I have a minus x and a minus x, that's minus 2x, and minus 1 at the end. And that is it. So all our like terms are combined. All right, number 5 is another foiling problem. So if we FOIL this is the cube root of a squared, and then we have plus 17 cubed root of a plus another 17 cubed root of a, and then 17 times 17 is plus 289. All right, in the middle, these are like terms. So we have cubed root of a squared plus 34 cubed root of a plus 289, and that is your simplified answer there. Okay, number 6, first step is to rewrite this 3 times. So j minus 2c is going to be repeated 3 times. And then let's FOIL. I'm going to FOIL the back 2 and then distribute that front 1. So this is j squared, and then it's minus 2jc minus 2jc. So that'll be minus 4jc. And then if you do the last, that's going to be plus 4c squared. All right, then we still have this j minus 2c in the front that we need to distribute. So if we distribute the j, that gives us j cubed minus 4j squared c, and then minus or plus 4j c squared. And then we distribute the negative 2c, so negative 2cj squared. And then we have plus 8, and that would be jc squared. And the last pieces, that would be minus 8c cubed. All right, now let's look for like terms, see if we have any. I don't see any j cubed, so we'll just rewrite that. But this minus 4j squared c is like this, as the variable parts are the same. So that is going to give us minus 6j squared c. And then this plus 4jc squared plus 8jc squared, that will give us 12 plus 12jc squared. And then at the end, we still have the minus 8c cubed. And then that is as simplified as that will get. All right, now we're going to go backwards and do some factoring. So we first always check for GCF, which in number 7, you can take out a 2x, leaving you with 4x squared minus 25. And then this is a difference of squares, so we can factor that as 2x plus 5 times 2x minus 5, and then you still have the 2x that you took out at the front. And this is your answer for number 7. All right, number 8 has a typo, so make sure you change this to an 8x, not to a 12x. All right, so now let's factor this. I'm going to do guess and check, so I'm going to guess that the 16x squared is a 4x and a 4x. And then for my factors of 15, I'm going to use 3 and 5. Since it's negative, I'm going to put a plus and a minus. So now if I check my outsides, this is minus 20x plus 12x. Well, if I have minus 20x plus 12x, that's going to be a negative 8x, and I want a positive 8x. So if that's the only issue, I have a minus where I should have a plus. That means my signs are backwards. So my negative should go with the 3, and then the positive should go with the 5. So then that will give us a positive 8x. All right, if you want to use a different method for that, go for it, but I'm going to recommend guess and check. Number 9, there's a couple of GCFs. So you have to think of this as one big family and this as one big family. And notice they both have an x plus 3 and an x minus 7 in common. So then what's left over is going to go back here. So in the first family, I'm still left with a single x plus 3 because I've got 2 of them. And then we bring down that minus sign. In the second family, I still have an x minus 7 because, again, there are 2 of them. So now in the front, I still have x plus 3 and x minus 7. Then in the back, I can simplify this. So I can drop the parentheses around this x plus 3, but then I need to distribute this negative, giving us minus x plus 7. Then notice these x's cancel, and 3 plus 7 just gives me 10. So I have 10, we usually put that at the front, x plus 3 times x minus 7. And that is your final answer for factoring number 9. All right, number 10, you should be noticing that 27 is a perfect cube and 8 is a perfect cube. So this is a difference of cubes factoring pattern. So I figure out what cube gives me 27x cubed, and then minus what cubed gives me 8. So you can probably figure out this is 3x and this is 2. So in that formula on your factoring sheet, this is your A and your B. Let's fill it in. So it's A minus B, which is going to be 3x minus 2. And then A squared is going to be 9x squared when you square all of this right here. All right, and then it's plus A times B, so 3x times 2 is 6x. And then B squared at the end, well, 2 squared is going to give you 4. And then that is completely factored. All right, yeah, so just FYI, this back part is prime, so that's never going to be factorable as long as you took out a GCF at the beginning. All right, 11. We're going to do a substitution here. So I'm going to say let u equal that x plus 4 quantity. Because then I can rewrite this as u squared minus 6u minus 16, which is a lot easier to factor than what I have now. So I'm going to try to find factors of negative 16 that add up to negative 6. And those two factors are minus 8 and plus 2. But I don't want u in my answer. I want x plus 4. So I'm going to go back, and where I see these u's, sub this back in. So x plus 4 minus 8 is in your first factor. And then x plus 4 plus 2 is in your second factor. And then this just becomes x minus 4 when you combine those constants, and x plus 6. And that is completely factored. Now in this one, could I expand this x plus 4 and then square that and then distribute this and combine like terms? Sure, you could do it that way and then factor whatever you're left with. Either way, you should still get this answer here. So you can do that the long way if it makes more sense to you. All right, number 12. This is another one where we're going to do some guess and check. Just so you are aware, this should be a V in the middle. So the variables are all the same. That is a typo. So if we look at this, we know it's going to be something to multiply to give us 6v squared. I'm going to try 3v and 2v. And then factors of 12, let's try 3 and 4. Now, if this is a plus and the middle is a minus, we know these are both going to have to be minuses. So there's my guess. Now we check. This is going to give me negative 12v. This is going to give me negative 6v. That is not going to give us negative 17v. So we're going to have to try something else. I'm close to negative 17v. So here's what I'm going to try. Since it's close, I'm still going to use 3 and 4. But let's switch them. Let's put the 3 with the 2v and the 4 with the 3v. Let's put this here and this here. Now let's try it. So if I FOIL now, I get minus 9v minus 8v. And hey, that's going to give me my minus 17v in the middle. So that right here is the correct answer. All right. And again, if you don't like guess and check, you can do those other methods like split the middle or slide and divide. But if you want help with those, you'll have to see me outside of this video. All right, 13, we got a lot of factoring to do first. So we're going to factor every piece. The first numerator you can factor into x plus 1 times x plus 2. And then the denominator is going to be x minus 2 and x plus 1. And then divided by, we could take a 9 out of the top. So this is 9x plus 2. And then in the bottom, we have x plus 2 times x plus 5. All right. So now everything's factored. We can do keep, switch, flip. So we'll keep this as x plus 1, x plus 2, over x minus 2 times x plus 1. We're going to switch to multiplication and then flip this second fraction to x plus 2 times x plus 5, all over 9x plus 2. All right, now we can start canceling. I've got x plus 1s to cancel, x plus 2s to cancel, and I think that's it. So if we write what's left over, we have x plus 2 times x plus 5, all over 9x minus 2. And that is as simplified as we can get this. All right, in 14, we're going to subtract, so we need a common denominator, which in this case, we're going to get that by just multiplying the top and bottom of this by x plus 1, which is the other denominator. This one we're going to multiply by x minus 3, which is the second denominator. All right, so here's what this turns into. Distribute in the top, and you get 7x minus 21, all over x minus 3 times x plus 1, minus, and then I'm going to actually do this. I'm going to make this plus a negative. So let's make this plus and then distribute a negative 5. So we get negative 5x minus 5, all over x minus 3 times x plus 1. Okay, we know our answer is going to be over x minus 3 times x plus 1, because that's our common denominator. And now in the numerator, we can just combine like terms. So we have 7x plus negative 5x, which is 2x. And negative 21 plus negative 5 is minus 26. And I'm just going to leave my answer like that. If you want to factor it 2 out of the top, you can. But it is not going to cancel anything, so let's just leave it. All right, 15, I'm going to show you the way by figuring out the LCD and then multiplying everything by that. So if you look at all of these denominators, it's the lowest number that they could both go into, which is 4, and the lowest, it's really the highest exponent. So 4x squared is your least common denominator. So what that means is we're going to multiply all of the numerators by 4x squared. So this numerator and this numerator and this numerator, and this numerator. Because what that will do is cancel out all of these smaller denominators. So this 4 reduces this 2 down to a 2x squared. This x cancels the square, so we're just left with 4x up top. The 4 cancels down here, and the x squared cancels down here. So now we write what's left over. In the top, we have 2x squared times 1, so this is just going to be a 2x squared, plus this 3 times 4x is 12x. That's all that's left in the numerator. In the denominator, we have 9x squared, and then we have a minus 1 times 4 is just 4. All right. Now, what I'm noticing here is that we can do some factoring. So let's actually try to factor this a little bit. If we factor, we get 2x times x plus 6. And then in the bottom, that's a difference of squares. So we can say 3x plus 2 times 3x minus 2. But I'm noticing that nothing cancels here. So at this point, I would just say, okay, I took the time to factor it. I'm just going to say that's my answer. All right, the reason you want to factor is because maybe one of the factors will cancel, but not in this case. All right, number 16, first step is to factor. So in the bottom, we have x minus 3 times x plus 1, and then plus 5 over x minus 3. So the second piece is actually just missing the x plus 1. So we're going to multiply top and bottom by that. This is going to turn into 7x over x minus 3 times x plus 1 plus, if you distribute 5, you get 5x plus 5 over x minus 3 times x plus 1. So we know our answer is going to have x minus 3 times x plus 1 in the denominator. And in the numerator, we can combine our x's, giving us 12x, and then that plus 5 will just stay there. And that is all you can do there. All right, and last but not least, we're going to rationalize these denominators. So in number 17, we're going to multiply by 1 plus root 7 in the top and the bottom. That's the conjugate of the denominator. So in the numerator, always distribute. You get 2 plus 2 root 7. And in the bottom, you can just multiply your firsts together. 1 times 1 is 1. And then your last together. Root 7 times root 7 is 7, so this is going to be minus 7. All right, so that's going to turn into 2 plus 2 root 7 over 1 minus 7 is negative 6. And since these can all be divided by 2, that's going to be our last step, is to reduce this to 1 plus 1 root 7 over negative 3. All right, and that is all we can do there. All right. Last but not least, one more rationalizing problem. Here we're going to multiply by root 3 minus 2 root 5 in the top and the bottom. All right, so in the top we have to FOIL this. Okay, this is going to be 1 root 3 minus 2 root 5, and then plus root 7 times root 3 is root 21, and then minus 2 root 35. So you just multiply the root parts together. In the denominator, when you multiply by a conjugate, again, you can just do the firsts. So root 3 times root 3 is just 3. And the lasts, 2 times 2, that's going to be a minus 4. And then root 5 times root 5 is 5, so that turns into 4 times 5. All right, and then we can't really do anything in the top because there are no like terms, so I'm just going to rewrite that. But in the bottom, we can do 3 minus 20, which is negative 17. I don't know what that was. And that is really the best you can get that looking when you rationalize it. All right, hope that helps. If you have any questions, feel free to email me or try to stop in before your test. We'll see you around.